First one have an R with it?
No.
So how many do we have to take away from it?
Minus 1.
1. So it's to the n minus 1 power. So this is your general form.
Yeah.
You can put like a n minus 1 as an exponent.
Sure. Sure. In fact, Ian, give me a number. Any number you would like. 32. Ian is saying, I would like to find the 32nd term in this expression, in this sequence. So Ian, let's do it. What's A equal to, Ian?
Negative 8.
Negative 8. Times, what was the ratio?
Negative 1.
Negative 1/2. To the what power? You said 32, right?
Minus 1.
So it's going to be 32 minus 1. Correct?
Yeah.
So this is negative 8 times a negative 1/2 to the what power? 31st. Now, I want everybody to sit there, put your pencils down, put your hands on your head. Lucas, now, I want you to think back a chapter and a half. Negative fractions. Fractions are implied by what? Push hard.
Fractions.
Fractions are implied by what kind of exponent?
Negative.
Thank you. Put your hands down. All right. Take a look. Up here. Up here. This 2 is to the first power. Is this a fraction?
Yes.
Thank you. It would be negative 8. This negative sign has nothing to do with the exponent. Times negative. If we bring that 2 up to the top, what would it be? 2 to the what power? First? Negative first. To the 31st power. This is called, we would multiply this out, and this is something I want to show you what happens on our calculators. Are you ready? So we have to raise 2 to the negative 31st power. Do you think this is going to be a very large number or a very small number?
Small.
2 to the negative 31st. This is going to be negative 31st. It's going to be like dot, dot, dot. It's okay, Lucas. It's going to come up in just a
It's
second.
going to be a big number because it's negative 2.
But it's negative 2 to the negative 30. It's going to be a negative number, but it's a negative 31st power. Negative 30, negative 31st. Like 10 to the negative 31st power?
Oh, buddy.
Okay, so here we go. Yes, dear. You may.
Does this go both ways?
Yes. So here we go. I need to get rid of what I was doing with algebra 1. So what is our... So folks, what is it that... I'm going to hit clear so we get a nice clean screen. What was our formula that we had way over there from... What was our... A was what?
Negative 8.
Negative 8. Negative 8 was our first term? Yes. Negative 8. I'm going to open a parenthesis, and then it's negative 2. That's the to the button right there. To the negative 31st power. I don't know if it'll know what that parenthesis means up there. But let's see. Enter. All right. So there's our answer.
A little E. Oh, there's the E thing.
So there's the E thing. Where's that E thing? What does this E thing mean?
To the negative 9.
What's to the negative 9? 10. Now remember that's in what kind of? Scientific notation. So I'm sorry.
I think you lost your game show.
I lost my game show. Never will I lose my game show. So here we go. What is it? What does it say?
3
Read it to me, Riley.
3.725290298 e to the negative 9.
So what does that mean, that e to the negative 9? It means that we're multiplying by 10 to the negative 9. So how do I do this?
You move the thing a lot.
You move this how many places?
9.
9 places. And how many zeros do I need to add?
8.
8. 1, 2, 3, 4, 5, 6, 7, 8, 3, 7, 2, 5, 2, 9, 0, 2, 9, 8. There you go, Ian, on the game show. There you go.
We have to write that down.
No.
That's a small.
So that's how you do
We
it.
could just, if I were on the game show, I would ask an expert and I would call you.
Okay. Call him, call me. Matthew.
So you know those, like, you know, what you just did, where you did
the exponent and then an exponent.
Mhm.
Can you do that like another exponent?
Mhm. Because look at this, watch this. If I said, let's make it easy on ourselves, okay? If I said 3 to the third power to the second power, would you agree that's 3 to the third times 3 to the third, right? And then how many, that's really 3 to the sixth power.
Yeah.
3 to the 6th, correct? When you have something called a power to a power, you just multiply them. So if you had 3 to the third, to the second,
To the fifth. Yeah.
to the 5th, it would be 3 times 2 is 6, times 5, this is 3 to the 30th power. That's getting big, really, really big. Ruby?
Are we supposed to do like the negative thing in our head?
No, the book ain't gonna ask you anything like this. But I think it's a disservice to you to, truly scrumptious. You two are truly, do you remember that song? That was from Chitty Chitty Bang Bang.
Bang Bang.
Oh, do you all know that movie?
I love that movie.
You've never seen it?
Never.
Chitty Chitty Bang Bang? Oh my goodness. Okay, Ruby, here's my theory. Ruby, ladies and gentlemen, watch closely. If the problem was this, and it said give the next 3 terms and what the common difference is, I find that quite boring. I find there's a level of learning when you can say, wait a minute, I can put this on the table, and I can tell you any term you want to know. It's full of work to do the multiplication. But I think it's important to know that there's a patterning effect. There's another kind of patterning. And the third kind of sequences are what we call other.
Wow.
Well, there's no pattern. And here's the deal with other. I can't stand working at one board. Okay. Here's like an other. 1, 2, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 2, dot, dot, dot.
Okay.
No, it's like saying it goes 1, 2, like 12, 122, something like that. You can see what the pattern is, but there's no mathematical formula that you'll ever be able to get to the next one. Or if it went 12, 13, 13, 12, 14, 14, 12, 15, 15. You can see a pattern, right?
Mhm.
But there's no formula you can put together for it. So that's called an other.